Hello, everyone. Good morning and good day to those joining from outside of the country. Good morning. Good morning. Please send notifications to your colleagues. Let them join quickly. We have a lot to achieve today. We have a lot to achieve today. Hello. Can you all hear me? Okay, so we're waiting for a few more people to join. Uh, Good morning. Good luck. Good morning, Hans. Hassan. Welcome, Haske. Welcome. Welcome. We have a couple of things to talk about. I have a couple of things to talk about this morning. Welcome, Abdulaziz. Please tell your colleagues to quickly join. We have a lot to talk about this morning. Yes, welcome, welcome, everyone. Welcome. As you are joining, please inform your colleagues. We have a lot to talk about. The reason why I'm waiting is so that we don't have to repeat ourselves. Yeah, I can see you as you're joining. Welcome. Good morning, Michael. Welcome. Michael Ladi, welcome. Abdul Salam. Yaron, welcome. Rukia, welcome. All right, so we appreciate our sponsors and those organizations that brought this opportunity to us. We appreciate Bayes University most especially for this opportunity. We thank the World Bank for this sponsorship, the Ideas Program. Thank you. NITDA, the National Information Technology Development Agency. Thank you. Thanks to Ministry of Education. Thanks to Jigawa State Government. And thanks to Dominion Blockchain Solutions for this opportunity. But like we always do, and we always say, more thanks to our own most important people, that is you. Thanks to you for always making time to come and join our program. I want to believe that in these past weeks, we'll be able to get something good. Excellent. So, yes, jumping into the conversation of today, we have my lecture assistant, Mr. Dami, is a blockchain programmer. He's going to be taking us on today's topic and today's course for the next 4 weeks. For the next 4 weeks, Mr. Damilola is going to be taking us on blockchain development, okay, blockchain programming. Now, blockchain programming is not compulsory. it is for those that want to focus on the programming aspect of blockchain. It's not compulsory. It's only for those that want to focus on the programming aspect of blockchain technology. So it's not compulsory. However, I would advise that everyone listen, go through the training, even if you don't want to become a developer. This is the secret of this industry. If you understand, at least you have a bird's eye view, a fair understanding of the technology cut across spectrum, you will become a round peg in a round hole. So even if you are a lawyer and you are focusing on compliance, or you are a general practitioner and you have gone into compliance, or you are just a consultant, a blockchain consultant, or you are a marketer, or you are an analyst, even a graphic designer, if you understand the basics of programming, even if you're not a programmer, when it's time for you to speak with management or to speak with a client, you'll be able to understand what the programmer is saying. If there's a challenge with the product and they ask you to speak with the programmer, when the programmer is talking to you, it will not sound like garbage. That is why it is important to have an idea of programming. So we are not saying that programming is compulsory. Programming is one of the elective of this course. We've done the two compulsory ones. The first was blockchain fundamentals. The second was blockchain compliance. We have done those two. Programming is not compulsory. DeFi trading is not compulsory. Then community management and community marketing is not compulsory. But I will advise you all to go through all of them. So the next compulsory one is actually the Capstone project, right? So Capstone project is compulsory. Now you will see the reason why this programming is advisable for you to take. So when you are doing your Capstone project, perhaps you will have only one or two devs, maybe one or two developers in your group. You may be the one to help your developer work on the idea and expand it whilst he or she is doing the actual coding. All right, everyone. Sorry about the network glitch. It was from my end. Your audio is fine. The network glitch was from my end. Sorry about that. Admin, please bring the slide up on screen. Bring up the slide. All right, so our lecture assistant is here, Mr. Olaseyinde Damilola. He's going to be taking us on blockchain programming for the next 4 weeks, like I said. Please pay maximum attention. He's going to be guiding us on blockchain programming for the next 4 weeks. Pay maximum attention. Then he will also be guiding us on the ICP blockchain, Internet Computer Protocol, because that is the reference blockchain for your Capstone project. The reason why we are doing that is we have an event coming up and there is a competition coming up on that event. Tokenized economy is coming up on the 3rd of October, and 4th of October, the second day, is the blockchain competitions. The two best projects will be selected by the admin. They will submit it to me and we will feature it. We'll feature the two groups on the second. All of you projects, we have about or admin, please bring up the slide while I go off screen so that trainer can use it to train us for today. For your capstone project, please continue engaging. For those that have not responded to on LinkedIn, please pardon me. We are going to get all that sorted out this weekend. Please do not send me any email. If you send me an email, I may not respond because my email is full. So whilst I'm working on that, that's why I said send me email in on LinkedIn. Do not send me any mail to my Gmail. Send to my LinkedIn inbox. I will respond to you there, hopefully before the weekend runs out. If you have any issue, come to me there. Please do not just send any unsolicited messages. Only issues concerning your capstone projects. Then if you have any issue concerning quiz, only those two. I am not in charge of your ideas registration number. I'm not in charge of dashboard. I am not in charge of attendance. So please do not send attendance issues on my mails. Okay. On LinkedIn, search for my name. You can see my name on your screen, Jude Ozegbe. Search for my name on LinkedIn and send me a message there. All right. Okay. So our blockchain programming facilitator, Mr. Olaseyinde Damilola, he is here, and I'll be yielding my mic over to him. Thank you, and enjoy the rest of the class.
Hello, good morning, everyone. My name is Daminola Olasende. I'll be taking blockchain programming section of this course for the next 4 months, 4 weeks. So I quickly want to use this moment to give a general overview of the blockchain programming course, what it takes, and then okay. So I need to quickly uh, share my webcam. So let me try to present. Hmm. Okay, it's coming up. The presentation is coming up. So okay. Um, I quickly want to just I quickly want to show. I don't know whether you can see my screen, my presentation, and then my webcam. So let me come again. My name is Damnola Lasende. I will be taking the blockchain programming for the next few weeks. And then in this my introduction, I want to present. Okay, come please. Is there can you see my presentation? So I you can see that in the beginning we have introduction to blockchain technology, and then the evolution of blockchain technology and blockchain role beyond cryptocurrency, and then the importance of blockchain developer. So um, okay, so I just want to make sure that we're able to be on the same page. I'm aware that everyone here understand what the blockchain is, and then the impact of blockchain on the society as a whole. And then this section is purely for programming purpose. So if you want to develop a blockchain program that can execute on the network. So let me just start with the early beginnings of the blockchain. So the main idea that evolved into blockchain is called the ledger. So many of us understand the ledger as an accountant, or the ledger as a kind of a document, a book that we use to record our transactions. If you manage a shop, so you can record your earnings and your purchases, and you can just have that ledger that where you have the debit and the credit, and then at the end of the day you're able to sum up the amount of people that are owing you the debts. You can also sum up the profits, and you can use that to now estimate the amount of goods in the store that you have left, and the ones that you need to add to the purchase. So blockchain, the ledger is just a normal thing that we used to keep track of our commodities and assets. So in that sense, later on, there is a need for uh, this concept of digital money. Digital money in the sense that we want to give you ability to spend on on the internet without re-spending the money again. So the problem is that if we are able to give you ability to spend a digital token, there is always a situation whereby people want to spend what they have, and still have it back. So the blockchain as a ledger is able to allow us to keep track of what we have spent, and immediately you are able to track that down. I'm talking about the normal ledger now. You'll be able to know that okay, oh, this is the table. But the fact that I'm not able to get feedback from the students, I don't know. I don't know how to know whether what I'm saying, whether the network is off or what I'm saying, everyone can get me. So I can't really interact with the audience. But let me just go straight to the point and then talk about 2008. The whole story started from 2008 when Satoshi Nakamoto invented BTC, Bitcoin. So the main technology of the Bitcoin is the blockchain. So that blockchain, as as you can see on a normal ledger, you can see that a ledger is like it has a different layers of tables. So the first initialization of the recording was more of like I want to show you. I can't really present very well. I don't know how to, but on every period, on every period, let's say every month, on a monthly basis, let's take a month as a period now. There is always a recording on the ledger that okay, oh, this is the amount of transactions that have been made, and then we have to close it. And by closing it, that means that we agree that all the inputs that are inside the ledger are authentic, and we sum it up. Then we move to the next month, to the next month, to the next month. So the blockchain is also like that. Is a periodic recording of transactions on on a database. So, like majorly, we can talk about the ledger as an example or simplest example of a blockchain system. But we can also let you understand that the blockchain is just an advanced database that is decentralized, that people can have access to it, and they can also uh, agree that this is the authentic value inside the blockchain, and they can also disagree that this is not the authentic value uh, recorded. So that is how what I can just say about the blockchain. But let's fast forward to 2015. So at 2015, there is also a very important thing that happened in the blockchain space, which is called Ethereum. So, as we know, Vitalik designed an application layer on the existing ledger technology, the blockchain technology. He is able to like have a application programming interface on top of that ledger, making it a Turing complete machine. So for the first time in history, apart from sending a transaction and receiving a transaction, we are now um, we are now able to. Oh, okay. Thank you, thank you. I have been hinted. So we are now able to just get a Turing complete machine. So what I mean by Turing complete machine is that there is an abstract computer. Let's say a computer is like you have a thought. The inside your thoughts. Let's say you have let's say I just want to describe an abstract computer. Okay. I want to start again from 2015. So 2015 is when the blockchain gets very, very interesting. So but at 2015, there's a guy called Vitalik. He designed a Turing complete machine. It's more of like an operating system on using the ledger. So when we are talking about a complete computer, that means that we're able to have access to memory, we're able to have access to computing power, and then both memory and clock computing CPU clock cycle can be abstracted away on the network, on the blockchain network. So these applications that can run on the blockchain network is called smart contracts. So they are called smart contracts because majorly, if you want to compute on the network, you have to compute decentralized in a way that is decentralized, and you have to have third parties involved. So immediately you're having a third party integration into your for you to execute your program. That means that there must be a solid contract between you, between your node on the network and other nodes on the network. So if you guys agree to share some resources on the network, we have let's say we have 2 gig of RAM, and that 2 gig of RAM, we want to use it. Let's say three people want to use it. So we at the initial state that we agree that let's say I am using 500 megabytes out of the 2 gig. Then the other party we agree that we are using that one is using 6 gig until we just share the resources properly. So by sharing the resources properly, we have designed a contract that okay, we have agreed with a contract that this is the amount of resources I'll be using on the network, and the other people also agree that those are the amount of resources they'll be using, and I will not be able to exceed my my limits on the resources on the network. So that just I'm just using that to explain the concept of a smart contract. But those contracts are not between human beings; they are between computers. They are between machines. So a contract is just a formal agreement between two parties, but this time around, it's not an individual. It is a formal agreement between two machines, a formal agreement between two computer programs to share resources on the network. So immediately they agree together and they said, okay, we want to share resources. You remember that the system we are sharing now is not a physical system again. So if you go back, I told you about the Bitcoin evolution, whereby Bitcoin was just able to implement a ledger. So that ledger is purely for transactions, financial transactions. We want to send digital value and we want to receive digital value. That's all that Bitcoin uh, blockchain did. But there's a guy in 2015 that now advanced that concept by um, adding another layer on top of it. So the layer he added was the application layer. So that application layer is a bit complicated because we have a ledger that belongs to everyone. How do you now add an application layer on top of it that will share the same resources? An application is running on that ledger. Then it want to share resources because it's a distributed ledger. That means that that ledger is not only belonging to me. Many other people are having access to that ledger. And then by having us a copy of that ledger, that means that you are sharing your hardware resources with the network. So what I mean by hardware resources is the RAM, the internet that you have on your machine, the RAM on your machine, your hard disk, and your clock speed, your computing clock cycle. So you are sharing that with other people. So your own machine is a node, your own computer is a node, and you can also do the same thing for others. So other people can also have access to your computer and share the resources on your computer. So that's like what's it called? The distributed mechanism. That's how the distributed mechanism work in the smart contract abstraction. So now let me just formally define smart contracts so that I can expatiate on what we can do with smart contracts. So a smart contract is like an application that can run on a blockchain. So there are thousands of blockchain this time around. So, but all of them are actually from this concept of 2015 concept by Vitalik. So this allow for automated and decentralized applications. So these are called the dApps. So they call them decentralized applications or decentralized smart contracts. So the reason why they are decentralized applications is because they are applications that are actually shared on different networks. So if I build a software now, and that software, I want it to run, let me use normal software language, let's say an Android app. So And that Android app, the reason that that Android app is not a DApp, it's not a smart contract, is because if I build an Android app and I install it on your laptop or on your phone, on your Android phone, what is going on is that it is only going to use the resources of that your smartphone, that your Android phone. It is not going to share the resources of other people's phone, because that Android app is a single app. Is running on your own operating system. It's not running on other decentralized operating systems. So that means that it is not a smart contract. A simple Android app that is not using the blockchain is not a smart contract. Now, the difference between a smart contract and an Android app is now that that Android app, now assuming I now design an Android app, and that Android app is now using a blockchain network. So what I did was that the Android app is going to be deployed on the network, not on my own device. So most of the activities of data storage, data sharing, database, everything is going to be on the network. So that means that that network is a combined computer. So we have a distributed computer that is not just my own computer alone that is contributing to the network, and other people's computer are also involved. So in that sense, I'm able to share the resources of other people computer and their own consensus too. So this is where the concept of consensus enters. So consensus is like trying to consent to an action or an activity. Let's say we are sharing a distributed ledger now, and I recorded a value. Let's say I recorded I bought a bread 500 naira. I recorded it on the distributed network. Let's say I have a ledger. I'm just giving you an example of a ledger of a decentralized application. So this decentralized application, I just built a ledger. So that ledger is to keep track of what I bought at the grocery store. So buying a bread at the grocery store and keeping track of the price at which I bought the bread at on the ledger, on the distributed ledger. Someone else can dispute it. Someone else can consent or disagree with it. So the fact that I write that I wrote it there that I bought bread at 500 naira is not going to be the final say. There must be some mechanisms that we verify that as true. So we are trying to know what is true and what is not true. So that is where the concept of consensus and then consenting comes in. So if you want to just use the ledger now, and the ledger is not just my own uh, account, it belongs to other people too. So by writing it there that 500 naira, I bought 500 naira bread in Kaduna. So 500 naira bread in Kaduna, the same place I said I bought that 500 naira bread in Kaduna, another person can go there and verify it whether it is true. Let me try to present the slides because this is what we are working on. Okay, I don't come. So, oh, I don't know why the slide presentation is not coming up. I have the slide there, but I can't just present it. I will still get to be able to do that. So, what we are working on is actually blockchain programming. I'm just giving an introduction and overview of the whole thing. So, I'm at the smart contract concepts, started from 2015. And then now, let me just move on from the smart contract concept. I've been able to define and explain now the dApps and smart contracts and the concept of consensus. So, uh, with that framework, I'm still going to give more details. All these things I'm explaining, we are still going to have a kind of more practical overview, programming, and then testing overview of the whole thing. So, I just want to give a kind of brief explanation of, I don't want it to be too technical yet, so that you can have a abstract concept of everything I'm talking about, and I'll be writing very soon. So now, This decentralized applications is a very big thing since 2025, 2015. So what we're able to do with decentralized application is that we're able to build several applications on the network. Talk about Facebook, talk about YouTube, talk about WhatsApp, talk about any type of application, talk about health management systems, voting systems, um, even finance, talking about decentralized finance, and also NFTs when we're trying to store values, and then government management system, bookkeeping systems, and then there are many other things that we can build on the blockchain. So now there are two things I still want to talk about. So let me talk about decentralized finance. So decentralized finance is a concept in decentralized finance is a concept in it's a concept that started since 2015. So what we mean by decentralized finance is that there are some financial services that can actually go on the blockchain because we can use the concept of consensus to be able to know what is true and what is not true, what is a real transaction and what's a fake transaction. So decentralized finance is called DeFi for an abbreviation. So DeFi is a concept like in the financial industry, there are some existing traditional finance structures like banking, like loan, like exchange, like currency exchange, and there are some things like uh, storing value. Let's say you want to just wallets. Let's say storing of value. So all those things are kind of things that already exist in traditional finance. But as the advent of this blockchain technology and smart contract concepts, we're able to design those things on the network. So let me move on to NFTs. We are familiar with NFTs. So NFT is just a way of storing digital value. So normally we understand the concept of arts. So like Leonardo da Vinci, he has a lot of artworks, and then those artworks like concepts and then all those artworks can be stored. Like there's a valuation to do those arts. So just like storing, there's a way we add assign value to a unit of gold. So if you have 2 ounces of gold now, there's a particular amount of dollars that's assigned to it. That is a value that, let's say we assign that unit of gold to so amount of dollar. Let's say we have 2 ounces of gold, then we have 0.10 dollars to 2 ounces of gold, or $1 to 2 ounces of gold. So assigning this is the concept of assigning value to a particular uh, asset, either digital or physical, is what they brought to the blockchain in terms of non-fungible tokens. So there are some token systems, token frameworks like we see ERC to. I don't want to go to the technical details yet, but what I'm trying to say is that there's an existing format of storing value on the network, which is through BTC or through normal token that we can have a fraction of it. So like normal naira, you can have a fraction of naira, which is kobo, and then dollar. You can also have a fraction of dollar, which is cent. You can have fraction of existing currencies. Now that's the same way it is on the blockchain, whereby you can have a fraction of Ethereum, which is GUI. Ether. You can have a fraction of Ether, which is a GUI. You can also have a fraction of BTC. So this is existing currency, like they're able to have a kind of crypto. Let's say we're able to simulate existing traditional finance concepts in terms of fractions of a particular value, a particular unit. So we can have another fraction of that unit. So if you are talking about value, then we are talking about a unit of value. Then we can also have a fraction of that unit of value. It's just like it's purely measurement in terms of let's say we are using kilogram to measure weight. Then we can have a fraction of kilogram, which is a gram. So those concepts are designed. Thank God it's back. So those concepts are designed. This is where I am. Okay, here. This is it. So those concepts are designed to actually get the same type of financial structure we have in the traditional finance on a decentralized format on the blockchain. So now, let me now leave the existing currency or token that is coming from the blockchain, like Ethereum or Bitcoin, and now goes to the concept of non-fungible tokens. So these non-fungible tokens can't be fractionized. We can't have a fraction of it, unlike the existing cryptos tokens that we have, like this Ethereum or Naira or this normal currency that we have, that we can have a fraction of it. Now, we can have a fraction of an NFT. They call it non-fungible tokens because they're also having values, but their values can be slashed. We can't have a fraction of the value. So they're also serving as a storehouse of value, but the issue is that we can't fractionalize it. So this concept is coming from art. Let me use an art example. So let's say we have a paint now, um, a um, a design, let's say by Da Vinci, a design that is a whole artwork. So we can value the artwork. Let's say we are assigning, let's say, $10,000 to that artwork. But the problem is that we can't split it up. We can't split the artwork up to pieces. We can't have one artwork cut to four because it's not fungible. I'm just explaining the concept of non-fungible tokens, NFTs. So that's why we cannot say that this asset can be fungible, unlike the other fungible tokens like Ether or BTC or any other currency. So now, in this case, this thing started coming up from 2015 to 2017. The concept started coming up from 2017. It blew up very high in 2021, and everything came back to plateau again from 2022. So now these are examples of what we can do with the blockchain system using smart contracts. So all these things are smart contract protocols that are giving us ability to be able to design concepts from the normal natural finance into the blockchain. So we can also have some enterprise solutions concepts like what I mean by enterprise solution is that normal enterprise solution is like the normal enterprise systems that we have now, we can also bring them to the blockchain. So there's an example of enterprise solution. Let's say the supply chain of a company. Let's say there's an enterprise now. There's a company. Let's say this shop price is an enterprise. So in that enterprise now, there's a way they get their supplies from different vendors all around the world for storing their they for they're able to get their supplies from different sources. So, but they want to manage the supply chain so that there won't be any kind of fraud involved. So they are able to use the blockchain technology to also do something similar. So that's what I mean by enterprise enterprise solutions. So you can design a smart contract that will be an application, and that application will be an enterprise application that will keep track of supply chains. And another thing can be data integrity on the enterprise level. We can also do cyber security too on it. So we can also extend our smart contract softwares to public services like voting systems. We can design voting systems, and then we can also talk about verification of documents like license, and you want to make sure that anyone that you give a license to is authentic, and there's no way they can uh, uh, do a fake version of that license. So you can also design systems like that. So, but at the end of everything, the main interest is that the blockchain system has been developed to a level whereby we can scale these things. We can have more users. Let's say you can have 1,000 user on the network, and there will be there will be scalability. There won't be any lagging in operations. So there is another thing I want to talk about, which is the role of the blockchain. That's the last thing. The role of the blockchain developer. So, as a blockchain developer, um, as a blockchain developer, okay, I want to attend to some questions there before going to the last section. So, there are some questions there that some people are asking me. What is liquidity and value are different words with the same meaning, right? So, this is going too far into finance. So in finance, there's a concept called as an exchange. So before you can talk about liquidity, you have to talk about a market. So for you to, I'm just answering the question of Bilkisu Sani. You asked that question 12:27 p.m. today during the lecture. So I just want to answer that. So you are asking that if I may ask, liquidity and value are different words with the same meaning, right? No, they are not. They are not having the same meaning. I just want to clarify the meaning. So if you have a market, so a market is simply a place whereby there's demand and supply. So there's a demand for a particular asset and there's a supply for it. So what it means to have a liquidity or a liquid market is when there is enough demand to cater for the supply and there's enough supply to deal with the demand. So that means the market is liquid. So if they are not saying that there's a liquidity somewhere, that means that if you bring, if you're able to, your demand is being like, if you increase your demand like a factor of 10, you're still going to be able to get supply. You understand what I'm saying? Let's say you want to buy something. Let's use the yam market, or let's say yam market as an example of liquid. Let's use to explain liquidity. So in a yam market, there are some people that want to buy yam with cash, and there are some people that want to sell yam. Now, if there is liquidity, someone on the selling side will talk about liquidity, and someone on the buying side will also talk about liquidity. So someone on the selling side will talk about liquidity in terms of cash. So if there's no cash to buy that person's yam, that means that the seller of the yam will complain that there's no liquidity to convert his or her goods, the yam. And someone on the cash side too, someone that's coming to the market to buy to buy yam, that person can also complain about liquidity, saying that there's no what's it called, yam to buy. There's not enough yam. If there's not enough yam, that means that there's no so now the reason why I'm using this example is because when it comes to the crypto market or the blockchain in those system, there is always a need to differentiate value from what's it called, dust. Like I think people that are into crypto trading and all these people, they give more justice to that. My own is to actually give a technical perspective to things. So on the technical side, what I can just tell you is that value is as a result of your side. So you will look at value as something you want to capture, not as something you're actually giving out. So most of the time, you want to capture value. That's how you perceive value. But the other party will also look at your own hand as value. So it's like it is swappable. So you can look at value, then the other person will look at liquidity. Then the other side is going to be like liquidity versus value. So they are swappable depending on the side you are. So if you want to buy yam, you are going to be looking at that yam as liquidity and looking at your own cash as value. Then the person on the other hand will be looking at your own cash as value and looking at you should be looking at his own yam as value and your own cash as liquidity. So that's just how they swap. So another question is how to solve scalability issue using during code. I will get it. We will get it next week. So let me just give an example of scalability issues using code. So let's just talk about the word scalability. Scalability is just about getting. So it's more about being able to grow as your demand is growing. Let's say we have a server now, and then the server can only handle, let's say, 2 to 3 requests, 2 to 3 users. So um, 2 to 3 users are kind of on the server and they are using it smoothly. Then there will be a time whereby the demand on the server can grow to 20 or 50. And once it grows to 20 or 50, then the server is going to slow down because the resources on the network is not enough to handle such amount of people. So directly, that means that if the machine slows down and is not able to deliver, is not able to deliver the to the performance level required, that means that the whole system is not scalable. Like when you're talking about scalability, is a holistic thing. It's not just from software perspective alone. So software will deal with that, but there's also a need for the hardware to scale up. So that's that. Um, okay. Let me now finally talk about the developers, importance of the developers in blockchain. So this is the developer world. It's very good that you're. It's very very interesting. This if you are a developer on the blockchain industry, you can do anything. You can create a currency, can create value, you can check out other people's systems. There's a lot of things because this is a purely open source community. So now, what is going to be your responsibility as a developer? You are going to be responsible for designing. That means that the architecture, you have to build. That means like a day by day activity like coding it and then testing. That's building. So you have to code and test and code and test and test and code. So back and forth until you have what you are building resembling what you designed. So it's more of like the normal process of building a house, whereby you have a design and architectural design, and then you keep working on the mortars and the blocks until the architectural design is looking like what you are building. So and then after that, after designing everything, you have to also maintain it. So you have to maintain the system. So there's an event that happened 2027, no, 2018. That's the hard fork on the Ethereum network. So that hard fork, these guys already designed the Ethereum network. They already implemented it. It's running. People are using it. Thousands of people are using it all around the world. But there was an hack that happened that due to the maintenance culture with this Ethereum team, they were able to quickly um, solve this hack issue and freeze the whole network up, and they're able to recover almost $75 million from the network back to the owners. So this is a very crucial point after designing and building, which is to maintain the systems. So there's another responsibility as a blockchain developer, which is the security and integrity. So okay, this will be tomorrow. This is just what I want to do today. So that will be security and integrity. So there are so many times that you write a code and then they want you to make sure the code is more secure and reliable. So they want to make sure that you are able to write something that is real. So you write a code and then auditors come on it and they audit your code. After auditing the code, you are going to now solve those problems they have pointed out during the audit. So you have to resolve that. Those are your responsibility as a developer to make sure that your code is having high integrity and is secure enough. So now the expertise of in cryptography and network security helps in to protect the integrity of blockchain systems. So there are three type of blockchain developers or blockchain developer knowledge. So there's one that is more of like the fundamental one, which is like you are working a systems layer. Uh, you are in the core layer, whereby you are designing the protocol and the protocol itself. So the protocol itself might be um, I will attend to those those answers very soon. So the protocol itself might be Ethereum itself, or you are designing another new network entirely. So that protocol layer is going to be uh, really, really rigorous with some kind of cryptography and network security expertise. You have to really consider so many things in the cryptographic space and network security space to make sure that what you are designing is reliable and resilient to attacks. So after leaving the protocol phase, then there's another phase on top of it, which is the application layer phase. So that application layer phase is when you are designing the smart contracts. So the smart contracts are going to be like what is going to be consuming the protocol layers. So if you design a smart contract now, the smart contract is going to just be what is going to interact with the users. So the user is going to use the smart contract to interact with the protocol. So the protocol is in the middle, is between the user and the protocol itself. So most of the time, the hack used to happen between the the application layer and the protocol layer. So most blockchain developers just design a smart contract and that is not really reliable. You could have heard about several hacks in the network or on different protocol smart contracts that they did not take time to actually verify their programs very well and they deployed on network on the main network. And in no time, the hackers will come and figure it out and exploit it. So, as a blockchain developer, you need to be able to ensure that your network and applications are secure and resilient against attacks. So, there are so many ways you can go about this. There are a way whereby you can actually you can drop your programs to um, all these competitions. There are some protocols online. I will share those protocols link next week. I will share those protocols link that you can drop after developing your applications. You can drop it for them to help you then to test it. So they can just analyze your program and your source code and test it and generate some reports for you. So and at the same time, that can also expose your system to some other malicious actors. So, but the main thing is to actually make sure that before deploying, you're able to verify all loopholes and close them. So the last question here is is um what's it? Okay. Is Copilot useful for tracking the malicious activities and change of code within a blockchain and network? Copilot, I this Copilot of a thing is something that just coming up. So Copilot is not really a security thing. It's more of like a productivity thing. So when you are a security expert, you can have a Copilot to do your work. Or if you're a developer, you can also have a Copilot to do your work. So as like using a Copilot to now track malicious activities and change of code within a blockchain network. So that is that is depending on the type of network you are dealing with. There are some networks that they did not allow you to. There are some level of this. There are some level in the network that you must have a um, your code must have the same identity with the real network code. Like you can download the blockchain code now and modify it and start being part of the network. But there are so many protocols that did not allow you to change the integrity of that code, that source code, or there's a layer that you can get to that the integrity of that network code can change up to. So there's application layer that you can write anything on the application layer, and once you deploy it, you can only deploy another program. So it depend there are some patterns I will show you that we use to do continuous CI/CD on the network, because CI/CD on the network is very complicated, not like the normal CI/CD on the using Git and all these ones on the normal programming section, like on the normal application level, like without the network, which is normal software programming. So CI/CD on the network is somehow not directly, it's indirectly, we are doing it indirectly, because immediately you deploy something on the network, you can't really reverse it again, it's gone. But that stuff you are deploying, you must deploy it in a way that you can still use some part of it, like it be like an API, ABI, some we call it ABI, application binary interface. So even though we have updated some part of the software, that means that we will still be able to have access to some part of the software, that we will ignore the rest of the section of the software and now use those part of the software to connect to the new software we design. So we are still working with the last deploy, but we are not using all the software, all the codes in the software. So all these things are going to. I just want to make sure that everything I'm talking about today, there's not too much complication in it. But I will note that I will make sure that I will talk about it when it's time for me to get more practical with you, because as from next week there won't be any long discussion I'll be having. So that next week will be for module 2. So I just want to make sure that the module 1 is clear, and this maybe to just talk randomly and explain some things. If you have any questions, you can ask, because of um, okay. If you have any questions, you can ask, because I will be. I think I'm done with my lecture now, and then okay. Is there any question? I'm still waiting for your questions. Okay, I don't know what's wrong with this software. It's not getting me live. It's not getting me live. I thought I was live since it's not going on live. So let me just entertain some questions. Okay, programming language that we are using. So basically, my aim is to actually give you um, something that you can use to design a smart contract. I want us to be able to design smart contracts. So later on, we can now go deeper into the protocol level. But for now, for smart contract development and design, we'll be recommending Solidity, JavaScript, and then HTML, CSS. So majorly, our will be heavily on Solidity. By next week, from next week, we will deal with Solidity. So Solidity is very important. Let me introduce you to Solidity, but I think I will do that next week. But let me just talk about Solidity. Solidity is majorly the programming language invented in 2015 along with the Ethereum network. It's got developed better on 2016, but for now we're able to use it to write. So if you write a Solidity code, you can use it on almost 25 networks. On the currently, can just one Solidity code can be deployed on several networks. So we are sticking with Solidity. Is there any other? Can we learn programming in 3 weeks? Depending on the person learning programming. So if you are depending on your what's it called, or your existing knowledge, cognitive capacity. So if you have built some cognitive layers before, then learning programming in 3 weeks will be easier for you. But if you have no foundation, existing foundations, it may take longer time. So thank you too. Thank you, sir. So next week, I want to give us one insight about next week. So next week, I will drop an assignment here. So next week, I want you to prepare with just go through the internet, check on Solidity and JavaScript. Try to uh, write a code. It's not necessary you get it right, but try to just implement something. You know, just try to write a code on with Solidity. So I hope you get it right. I hope you don't get it. So no matter how you do it, if you try your best, but it will just prepare you for the lecture next week. Because next week we'll be dealing with this. So we'll talk about the centralized ledgers and then what's it called, the blocks, the chains, and the nodes. Um, we also talk about the maintainability. All these things we will be more practical next week. So there won't be like I'll be using abstract concept like I've been doing today. So that next week will be like so we really want to talk about fundamentals of solidity next week. And then those fundamentals of solidity will be what we will use to understand the network. So we will understand the fundamentals of solidity, then use that solidity to now understand the network itself. So we use solidity to understand the blockchain itself. So we'll be using ICP, Internet Computer Program. So I will also share a link on the ICP net, stuff. So you can also write Solidity on ICP. So for the Capstone project, we will be able to test different ideas. Just anything you want to do, you can just do it. Okay, thank you so much. I really appreciate it. God bless you. You can deploy Solidity on SRP system? We are not in this course. We are not dealing with SRP yet. We are not going to do it. We are not going to deploy. We are not going to deploy on SRP at all. We are not going to touch it. So we are not going to work on SRP at all. In this lecture. So we are going to deal with Ethereum and ICP. So bye bye. Thank you.
Hello? Hello, can you hear me? All right. Thank you, everyone, for joining today's class. I'm sure you were able to get something from it. Yes, Dimfa, for those of you asking, your capstone project is referenced on the ICP blockchain, and there's a reason for that. You remember I taught you at the beginning when we are doing blockchain fundamentals that there are various blockchains, but if you want to build a project, you have to choose a particular blockchain. And for the essence of the capstone, we are using the ICP blockchain. The reason for that is we want everybody to be on the same page. Okay? So we are going to be measuring apple for apple. We don't also want to build on a particular blockchain and someone builds on a different blockchain. This is for your project. Please, this is for your project and it is part of the instructions. So for those asking, make sure your reference blockchain is Internet Computer Protocol. You can go to their website, you can go to YouTube and learn more about ICP. It's actually a very simple interface. If you are not a programmer, don't stress yourself. Like I said earlier, you are not deploying the program yet. Okay? You are not deploying anything on the blockchain. Even this project you are doing, you are not deploying it on the blockchain. All you are doing is developing a presentation. You're just developing slides. But make sure that your slide is very catchy. Make sure your project idea is very attractive. And make sure that your project is something that can actually be developed eventually. Go through the documents that we have shared before. We're going to be sharing an updated one later. All right. So for those of you that have not found your names, just relax. You're going to find your names when we share it later. For those of you that I mentioned your groups on LinkedIn, to you on LinkedIn, reach out to your group members and show them the chat that I had with you so that they can add you to the group. We're going to send you the updated document later. Please do not stress yourself too much. The essence of the capstone project is just to show that you have understood what we have been teaching you. Okay? We are going to be guiding you on it. If you are done with yours, you can definitely go ahead and submit it. If you are done with your project, because some people are faster than some others, you don't have to stress yourself. You can submit it so that we can start assessing your work ahead of time. But if you are not done with yours, please, you have some time. Take your time and make sure that you do something that is very presentable. You have until September second week. I think 15th of September is the deadline for you to submit your project. So you have nothing to worry about. All right. The updated list will be shared in a few minutes. But even if you don't find your name there, do not stress yourself too much. We're going to be sending another update again over the weekend. The slide for today's lecture, you'll find it in the folder called BTC 105. BTC 105. That is blockchain programming. You are going to find the slide of today's lecture in that folder, BTC 105. Okay? Like I said before, if you do not have a programmer in your group, do not stress yourself too much. Just make sure that your presentation is very catchy. Make sure your presentation is very catchy. That is the important thing that you should work on, and not trying to look for a programmer that you don't have. All right. I think that captures the thoughts for today. For those of you that were not able to write your test, your second quiz in the past week due to network issues all around the country, For those of you that were logged out before you finished, please, if you have the screenshots, send the screenshots to my LinkedIn. Send the screenshot. We must see proof. We must actually see proof. So send the screenshot to my LinkedIn, and we're going to have a meeting with the admins. Then we'll see what we can do for you, only for those that had network issues. If you know that you had written your quiz and you are okay with it, please do not retake it. As a matter of fact, you may not even be able to retake it. But we see two entries in the quiz, both of them will be disqualified. If we see two entries for your quiz, both quizzes will be disqualified. Then back to your capstone project. Even if you are not up to 10 in your capstone project, go ahead with what you are doing. Do not worry. Even if you are not up to 10, go ahead with what you are doing. You will get your score. Now we've been getting reports that some people are not participating in the project. We will get the updates. So don't just think you can relax. Other people will do the work and you will get the score. No, you'll be shocked. We have some metrics we are put in place. If you do not participate in the project, you will not get a score. If you do not contribute to the project, even if your team wins, you will not be included. So we know how this thing is. We know how it works. So please cooperate with your team. Teamwork is what we are after. Teamwork is very important. So cooperate with your team, okay? And ensure that you deliver on your capstone project. It's very important. It will help you. Some of you will be shocked at the end of the day what's going to happen. All right, so that is it from our end today. Thank you very much for your time. We appreciate you. Please stay safe. We know the past few days have been very tensed in the country. Do your best to stay safe. The slide has been uploaded. Yes, I've just been informed that the slide for today's class have been uploaded. So please, you can go to the Google Doc and Google Drive and check for today's slide. Okay, good. I've also been informed that the Capstone project list has also been uploaded. So go to the Capstone projects group and folder BTC 106 in your Google Drive, BTC 106. Check for your names again and confirm your details. If your student number is wrong, please reach out to me on LinkedIn. If you cannot find your name, reach out to me on LinkedIn. All right, on LinkedIn, please, not my email. I appreciate that. And exercise some patience for me to respond to you because I'm responding to over 300 people on this project. All right, so BTC 105 blockchain programming for today's slide. You will see it in the Google Drive. I wish you all the best. Please coordinate yourselves, work as a team, work as a group. It will help you a lot. I know that some great ideas will come from this Capstone project. And if you have not registered for tokenized economy, you should see, if you are following me on LinkedIn, you should have seen some of my posts. Go and register for tokenized economy. It will be a game changer for you. From next month, we'll be making some announcement that will blow your mind. It will be a game changer for you if you are doing this program. And make plans to be there for the 2 days, October 3rd and October 4th. Make plans to be there. There will be some surprises for the people that are going to be there. All right. So thanks to Base University, thanks to all our sponsors, thanks to our admin and our technical team, to Marcos, to Awal, to Favor, and all the amazing people that have been working behind the scene to make sure that we have a seamless virtual experience. And to all of you for making our time to come again, thank you and God bless you. I remain Jude Ozebe, your facilitator for this program. Stay safe and goodbye.